Hey there, my name's Enrique, and I'll be going over computed radiography, the cassette, image acquisition with the cassette, direct digital acquisition, and flat panel detectors, both direct and indirect. Cassette. The front is made out of a radiolucent material. You see aluminum along the edges to prevent damaging. The back is made out of material that prevents backscatter, such as aluminum. The photon should be able to penetrate the radiolucent material, hit your IR plate, and prevent any type of scatter from hitting your image post. Uses special technology that is called photostimulable phosphor plate. The main components are barium fluor halide with europium activators. Once you expose your imaging plate to the X-ray photons will penetrate, causing a reaction with the europium and forming a lattice. The lattice happens when electrons on the outer shell of the europium jump into the middle and create light. That light is 50% of your X-ray photon, meaning that 50% is your image. Alright, now we've got our image. So, let's go to the processor. Now as you see, the processor has preset measurements, so this 8x10 will fit directly in there. You'll follow the red line, place it in, and then begin the image acquisition process. There are two types of processor. One is a slow scan, which means it'll move the imaging plate across the scanner, and then there is a fast scan, which is movement of the laser beam across the imaging plate. The laser beam itself, which is helium neon laser, it is contained in the image reader device. The laser beam reads the europium hole. The combination of the laser beam and the energy deposited in the europium hole makes the electron of center of the lattice to jump back, releasing a blue-violet light or blue-purple light. The blue-violet light is collected in the photomultiplier or photodiode, converting to blue-purple light into an electrical signal. The electrical signal, also known as the analog signal that has your original image, goes to the analog digital converter to convert the electrical signal into computer signal or digital signal permits in a binary code of ones and zeros. The software itself will then, through digital to analog signal, convert it into your image on your screen. The final step of the imaging acquisition process is when the image processor itself shines a high intensity light across the imaging plate to erase any of the latent image left on there. This avoids any ghosting of the image when you're going to use the plate once again. Okay, so here we have a flat panel detector, indirect. So, once we initiate the exposure, the photons will travel down, penetrate the body part, hit the detector area. Once that hits the detector area, it'll be transformed, the light energy will transform into an electrical signal, which will then be sent all across this wiring into this control unit. Once it hits this control unit will send the image to your panel. Since there are two different types of flat panels, we'll start talking about the indirect acquisition one. As I said before, the X-ray photons will cross the body part, hit the detector itself, and it will come in contact with the cesium iode or the scintillator. This will create a light reaction. The light will then go to the heart of the indirect panel, which is the ASI, or amorphous silicon. That amorphous silicon will send an analog signal or an electrical signal through the TFT, the thin filament transistors. Once those thin filament transistors hit the DEL, or the DEL, the latent image, their analog or electrical image, will be stored there. This stored image will be then converted with the analog to digital converter into binary code. The binary code will then be sent for sampling, and then you will have your image. Now, once we talk about the direct acquisition, one whole part is taken out. The section where there's cesium iodine reaction with light is taken out of the process, so the X-ray photons will come down, will directly hit your amorphous silicon, creating your electrical signal or analog image. Then it will be sent through the thin filament transistor, so your DEL to your analog to digital converter, which then will be sent to your screen. Now that we've gone over flat panel detectors, you'll be able to see how quickly this process actually happens. Here we have technique set for a hand. Now it's already loading on there. And there we go, it gives you a slight preview, and then it gives you the image. Thank you for your time. I hope you have learned a little about the CR cassette and how it's made, the imaging plate within the cassette, and how the process of image acquisition happens within the image processor. Also, flat panel detectors and how direct and indirect differ. We have come a long way from wet readings, but I am sure we still have a far way to go.